All right, just a brief add-on to the last video about graphing motion, so we'll call this more graphing motion. Now, I always like those fancy pens. Oh, there they are. Ooh, fancy. Okay. So hopefully you remember that if I have a graph, a DT graph, and it's doing something like this, the slope equals the speed. Yes. And that was in the last video, but I just that was easy if this is a straight line. Yes. So I'll put really easy if graph is straight. But that's not always going to be the case. So what happens if my graph is looking much more different? So I'm going to make a nicer that. Go back to pen. T and D, and we'll say that the graph is doing something like this here, making a curve. Okay. Now it's not so easy to find the slope of that line. So there are two things that you might be asked to find here. The wording might say average, or it might say it might just give you 2 times, or from t equals let's say 5 seconds to t equals 10 seconds. So if I need to find the average, and so let's go down here and I'll put the 5 here and I'll put a 10 here. And what you do in this case to find the speed, the average speed in this case, is you go up. Let me switch colors. It's green. You go up to the graph here. You put a dot. You go up from the 5 because it's telling me from 5, and then you go up from the 10. Okay, and you put another dot here, and then you draw a line. Yes, and you draw it from one point to the other. Okay? Bang, just like this. This thing is called a secant. Okay? And then you can find the slope of that to find the average speed or the average velocity if I'm dealing with a graph that is a vector here. Okay? So over here I'll write find the slope of the secant to get speed. I'm going off my page a little bit. There we go. Slope of the secant will give me average. That's like your code word in a question, a graphing question. You see the word average speed or average velocity. Bang, you got to think secant. It might not say average. It might say, what is the speed between from 5 seconds to 10 seconds? Boom, that's code in the question for draw a secant, find the slope of that secant, because it's not so easy to find the slope of a curved line. Now there's another type. I'm just going to go down a little bit, give myself some room here. Draw a new graph because there's one other type of thing that you might be asked to solve for here. Another type. Let's get black again. So I got my T, I got my D, I got my crazy graph, yes? And you might be asked to find, instead here, you might be asked to find instantaneous. Might be the code word in the question that you look for, or just one time given. Yes? As an example there, find speed at t equals 5 seconds. And again, so if let's just say that this is 5 right here, okay? I'm going to go up from the 5, boom. And at this point right here, I need to draw a tangent line to this curve at that point, tangent line. So I'm going to get my line tool out. I guess I can make it blue like that. Oops. And I'm going to come over here and I'm going to try and draw a tangent. Tangent touches the curve at that point only once. So that looks like a pretty nice tangent. Of course, there's going to be some leeway when I ask you to do a question like this on any sort of assessment, because some people might draw it a little like this, some people might put it a little bit more slanted, but you should try to have the curve your tangent line, the blue line, only touch the red curve at one point, right? The point that I'm interested in. This guy right here is called a tangent. Okay, and here we need to find. I'm going to scroll down slightly. Find slope of the tangent to get instantaneous speed or velocity. So just recapping, if you're asked to find an average speed or velocity, you get your two times, put dots, draw a secant between them, find the slope of this line that you've just drawn. If you're asked to find an instantaneous speed or velocity at just one time, for example, at t equals 5 seconds, where a question says find the speed at t equals 5 seconds, boom, go up from 5, dot, tangent line that only touches your red line once, slope of that line, and you're done.